All right, so with that, let us just quickly jump into Creo and let us have a look at how additive manufacturing helps in the industry. All right, so for my first part of my demo, I'll be using the metal printed bracket to show you some of the additive manufacturing process. So let us open that bracket here. And this model is created using generative design inside Creo. So with the generative design, engineers can interactively specify their design requirement and goals, and including the preferred material and manufacturing process. And the generative design will automatically produce a manufacturer-ready design, which they can use as a starting point or a final solution. And we had another webinar which we ran a couple of weeks ago, and we are very happy to share that link if you missed that session. So, so let us prepare. First of all, let us prepare our model for 3D printing. Now, when we're planning for 3D printing, the first step we need to consider is the build direction. Okay, because all of the steps, such as support structure consideration, placement on the tray, lattice orientation, and post-machining operations, everything based on the build direction. If you're using a polymer, support material does not matter a lot because support structures are printed in a low density format and can be easily removed by hand or washing later. But when it comes to a metal printing and parts like this, it's very critical to consider the support material because end of the day, it is a hardened piece of metal attached to a finished part, which you can only remove by post machining. Now, Creo identify the downward looking surfaces in the part that require support according to these critical angle and subcritical angle. And we can configure that, we can change it. We can also, we can change the optimization required based on some of these conditions like a downskin and support volume. And Creo will generate the best optimum build direction. And based on the build direction, it also will show us the critical angle required for the support material. Now it will take a couple of minutes to run this computing. So what I will do here is I will open a completed study here. And as soon as when I open this, you can see system shows me the optimum build direction here. Okay. And also you can see the support structure information required. Okay, so this actually got two colors here. One is the red color, which is the critical angle. Wherever this red color is, there should be a support structure attached inside the printer while 3D printing. And this yellow color is subcritical angle, but it's always recommended to have a support structure for the subcritical angle because it is also will help us to minimize the vibration and the heat absorption. Okay, and minimize the surface distortion and have a better finishing for the metal printing. What I have done here is I have actually did this design study based on the downskin area, but there are other design studies also, something like a minimal height for the model inside the printed tray, which is good for when printing a long slender models to minimize the vibration. There's another commonly used one is a shadow area, which will minimize the area that the model project into the printing machine in the XY plane. Based on the shape of the model, sometimes we need to reduce the build material required. This downskin area, which is I have used here, it will minimize the area that required for the support for the 3D printing. Okay, and looking at the result, the designers can, of course, take the important decisions based on the functional requirement and the surface finishing and the post-manufacturing of the metal printing. Now, once I'm happy with the orientation what I got here, what I can now do is I can take my model into an additive manufacturing setup where I have a configuration for my tray, where I can place here my component. straight away. I can actually place that in my tray here, that one, and then assemble that. Because I already have the tray, the build directions already created inside the model, system recognize that because we are exactly using the same model that I have been designing the generative design. The build direction is set up. All is exactly, it's not an exported model here. It is exactly a native Creo model with all the features and all the parameter informations, everything is being defined. And that is the beauty of the system here, because any changes I do in the design or any stages, it will propagate those changes inside my metal tray here. Okay. So now if you like to actually pattern or nest this component, I can easily do that here. Okay. I can say similar to Creo pattern tools, I can easily do that, in the tray. Again, optimizing that tray to maximize the efficiency of the printing. Now, if you're happy here, I can export this everything as an STL or a 3MF data here. But if you like to go ahead and if you like to create a support structure, Creo will offer a lot of support structures. That is, some of those templates coming from Materialize library, and which is you can actually go and change the support angle, the type of support types you would like to define. All of those can be modified here. Okay, and it will generate that support structure for you. Again, it will take a couple of minutes. So what I'm going to do is I have already created a support structure for you guys. And here we go. So these are the support structures I've previously run and created. Now, if you just look at a close look here, we can see wherever that the subcritical angle and critical angle have shown the support structure, it has created a structure here. And this structure is a completely editable structure. So for example, while I'm here, I thought that area is not really good because I need to do some critical post machining side. I have the flexibility here to delete that support structure if you really want to. It's not very recommended. And I saw an overhanging area which definitely needs some support there, but you have the option to delete if you really like to do it. Okay, or sometimes some of those areas I would like to redefine that support structure. And if if you have a license for reverse engineering extensions, it is nothing but an STL manipulation tool here inside STL, inside the regs. I have those similar, exactly the same option of the regs to manipulate that STL data for the support. I can maybe delete a portion of that, and maybe I would like to trim that. Maybe I would like to decimate it. I can clean it. I can refine it, and you have that additional functionality also. But you would like to, we need to have a Rex license for that. Okay, but the PTC Creo offer that functionality inside, that connectivity between Rex and the support structure. Okay, and now if you like, you can actually directly connect it to other printers. Okay, or if you like to do some analysis study, you can, for example, something like if you like to create a slices to see how the 3D printing will all work, like a slicing and things like that. For example, I would like to quickly do a clipping and to see how the slicing work. I can do that to get a better understanding of how the machine will be printing my job here. I can export the slices here one by one, or you can actually load the slices from once it's been exported, you can actually load that into Creo tray, and you can actually run the play and see how you can see one by one how each individual slices is going to create it and create the printing for me. Okay, so it's got heaps of options available to make sure you are actually doing a really correct job before you actually sending this model to 3D printing machines. You can do all this kind of analysis process to confirm the job. Now, once you're happy, what you can do is you can actually export this as a 3MO format, and there are, it is a modern format for exporting to 3D. Just do a file, save a copy, and you can still do a STL data, but you can also do a 3MF data. But the advantages there is it will export, unlike an STL file, it export the printer details, color, material, textiles, support materials to the printer. Okay. Now, in my second part of the demo, what I'm going to do is to show you a bit more on the lattices functionality inside Creo. Okay, so I'm going to use this pedal assembly here, and what my design intent to is to reduce some of the weight for that part here. Okay, so let's just open that part in a window of its own, and you can see I got a design intent here. The model weight here is 1.7 kilogram, and of course by adding some lattices I can reduce the weight of this part. Okay, so what I'm going to do is just to quickly show you some of those lattice functionalities. You know, we got beam 2 and 3D beams. We have 3D 2.5 lattices. You got formula driven. You got stochastic lattices. And I'm going to make use of the multi body functionalities here. I would like to convert that internal body into a lattice. Of course, that's a pedal. I would like to actually have that outside the surfaces of the pedal should be exactly the same. I would like to create only the inside of I would like to fill the inside of the part just with the lattices. I can configure my lattices. I can actually change the scale factor. I can go and change all these. Okay, just let me move this part. So I can actually go and again configure my lattices like the way I like to. And once you're happy with all the configuration, you can accept that, and system will fill that model with the lattices. Same way, I can actually go and change this one to a 2D lattices. I can change the orientation easily. I can change the type of that. Again, you can see you've got triangle shape or hexagonal shape. Again, the same configuration I'm using here. I'm going to use this body to convert into a lattices, and you can see that the regeneration time inside and the generation of lattices is very quick inside Creo. Okay. I can also go ahead and create other type of lattices inside Creo, like a stochastic lattices again. This is again, there are really nice tool here for creating Voronoi diagram and Delaney triangulation and things like that. Okay. So what I'm going to do now is I'm mindful of the time. So let us quickly jump back to the presentation here, and let me quickly go through what Creo is now offering with the high-speed machining extension. So inside Creo, we got a very dedicated tool for high-speed milling extension. Um, it offer very powerful roughing, especially on the constant load 3-axis roughing and conversion of 3+2 5-axis, conversion of positional 3+2 5-axis, and also it's a simultaneous 5-axis machining as well. It also have very good quality surface finishing tool, and it can finish very complex part, keeping the surface quality. Especially keeping the smooth cutting and linking passes, really modern strategies. You can see some of these pictures here. We can create very nice toolpath for surface finishing, avoid complex, more time on the polishing later on. Okay. It also have a automatic deburring tool path. To deburring it, sometimes take a long time especially for the production machining. A lot of time we need to do for deburring, but Creo HSM machining comes with an automated 3-axis to 5-axis deburring tool path as well. Okay. Maybe I just quickly show one tool path, and then I will hand over back to Alan for the questions. Let me just quickly close all these files here. Just to show you maybe the 3-axis bit, because just to show you how it's actually different from other CAM system and the traditional machining. So this is just a 3-axis pass here. It's called constant cusp. And just would like to show you the finishing toolpath that creates inside high-speed milling. People from the manufacturing background can see such a beautiful toolpath that is being generated. Okay, you can change the scallop height to make it finish, and avoid any chances of polishing and things like that. Okay, and finally, before I finish it off, I will just quickly show you maybe a 3+2 conversion, which is again a really good workflow for roughing. Because in the traditional approaches, for example, if I just do a roughing sequence here, we need to manually do re-roughing and roughing for this inside volume. Let me do one thing. Let me close this and reopen that model again. Okay. So when you do a 3-axis roughing, it's actually will be always have trouble to remove that, and then I need to do a manual re-roughing. But what Creo 3+2 conversion tool offer you here is it automatically will calculate first the 3 axis on the one Z axis, and it will automatically calculate that position roughing on the different axis.